everyone and welcome to a new discussion which is in continuation of what we have discussed in the previous discussion, and that is geologic formations as aquifer, and this is part 2. We have initiated this discussion about geologic formations, what is the importance of geologic formations and how these are in Indian terms, how they are distributed and they affect our aquifers and so on. So, let us start the part 2, and this part 2 is we know that earlier also similar kind of maps I have shown to you that probably 90% of all developed aquifers consist of unconsolidated rocks, primarily sand and gravel, and that is why a large part of Indo-Gangetic plain is shown here, which is our unconsolidated rocks, and this is primarily of sand and gravels. But one thing which is very important and which has been understood through various investigations, which are not only geological investigations but geophysical investigations, that throughout in vertical direction, throughout this Indo-Gangetic plain, it is not all the time you are having sand and gravel. There are layers of clay also, and these play sometimes roles, and sometimes you may get, because of too impervious clay layers, you may get also confined aquifer conditions. But what is the extent of each of these clay layers in subsurface conditions? So many times it is very challenging to know, and but nonetheless overall the groundwater conditions relative to other parts of the country are much better here. Because there is of course the Himalayas there, and big rivers of Himalaya like Ganga, Yamuna and other these Brahmaputra rivers and other rivers in Punjab, all they are supplying water and irrigating these lands and this Indo-Gangetic plain, and therefore there is a high recharge because of these unconsolidated rocks or sediments which are present here. So it is the very, what we would say, is food ball of the country. It is highly fertile, and the reason is the soils are favorable, and also you are having sufficient availability of water through surface water as well as groundwater, and a huge canal network in past 80-90 years have also been developed in this part of the country, and these canals are not throughout lined canal, they are unlined canal. If I give you the example of the one of the longest canal network in the country, which is Upper Ganges Canal, which starts from Haridwar, and the distributaries reaches up to Kanpur. So a large part of northwest or western Uttar Pradesh, starting from Uttarakhand and then Uttar Pradesh, is irrigated by this canal network, and a large part of this canal does not have the lining, and therefore from wherever it passes, these are mostly in the 95% of this canal network is unlined, and that means it is recharging the groundwater regimes, and therefore the water through wells, groundwater wells, are available quite easily as compared to hard rock terrains, which you can also see here, that how these hard rocks or terrains looks. They are little higher on the grounds as well as do not have that kind of availability of water. So these are the most favorable alluvial deposits as aquifers, as the heading says, are the most favorable aquifers in the country, if I am talking mainly about India. But in other countries, if such kind of setups are there, then the sufficient rainfall or such perennial large rivers are existing, then there should not be much problem. And now the example which we have seen here, if I take further in this much detail, this is of course the image from Google Earth, and which is showing where the Yamuna and Ganges are meeting near Prayagraj, and based on the manner that the occurrences of these aquifers, it can be divided in mainly 4 categories. This Indo-Gangetic plain, which is a very large part of India, very fertile and food wall of India. And so, first category can be water courses, which forms underlying streams channels as well as forming the adjacent floodplain. And you can see the, when we say floodplain, and you can see these curved oxbow lakes, that means they are indicating that only few years back or some years back the river was flowing in these areas. So, this is all, these are the all areas which river has visited, and paleo channels can be observed, oxbow lakes can be observed, and all these areas are very fertile because of a good soil and sufficient amount of availability of water. So, that the current flood plain is also very wide, which runs for few kilometers, and therefore, that land is also very fertile, especially for certain kind of crops, and because of course, the good availability of water. Now, this abundant or buried channels, buried rivers, which I have already mentioned, which are there all throughout this part of Indo-Gangetic plain, or in other parts also you can see. These are also very good aquifers, from where if you make a borehole not too much depth, still you will get a sufficient amount of water. The plains which have the areas of Indo-Gangetic plain which has not currently visited by these major rivers, those are also very good aquifers. And then there are other areas like the intermontane surrounding by mountain ranges, valleys, which are also there in certain parts, but they can also become good aquifers. But this last part need not to be in Indo-Gangetic plain. In some other parts, even in hard rock terrain where the river valleys are filled with alluvium and rivers are quite large or having large width, they can be also very good aquifers. Now, when we see these the setup here in a 3D perspective view, and also the fault system which is also shown here, that main frontal thrust is shown, and which basically divides the Indo-Gangetic plain and Himalaya. So, this is running between this, and from once you cross this MFT towards the north direction, then you are basically entering in Himalaya starting from Shivaliks. So, this part we call as the outer Shivaliks, and of course, the important part here is for us under discussion is Indo-Gangetic plain, and these areas are also intermontane basins in the Himalayan frontal zone. This is this area which is just in front of Shivaliks, and northern part of Indo-Gangetic plain, which is running parallel for hundreds of kilometers along the Shivaliks almost throughout the Himalaya, are having the best availability of groundwater. And sometimes when in higher reaches, if I give the example, see this is from Doon Valley area. So, this area which here, this is higher ground, and if rainfall occurs after some time, because this is Doon gravels, it is filled with gravels. So, water may not stay here and water will ooze out from these places. And I myself have seen in before the Shivaliks, the northern part of Indo-Gangetic plain, which is also called Babbar zone, is water is oozing out, or if there are some open wells, you can see that the artesian conditions develops where the water automatically comes out of the well. So, this is another very fertile land because of good availability of water. However, this land is also, large part of this land is having dense vegetation or reserve forest, protected forest, Rajaji National Park and Corbett National Park. All these are located near these Shivaliks, and they are well protected also. If because one has to know, one has to understand that Shivalik rocks are relatively not very hard rocks, and they are highly erodible rocks, and therefore, if these are not covered with forest, then you would have these will erode very fast. So, the protection from the forest point of view is also there, that is why these are surviving and intercepting the rain and allowing water to percolate down, and that appears in the Indo-Gangetic plain, and this along even this Babbar zone. This fault also plays very important role as also seen in the thermal images, especially during an earthquake event. It has been observed that whenever there is an earthquake in nearby this Himalayan frontal thrust, the water comes out near all along this MFT, and that shows that how the connectivity in subsurface about the groundwater is there. Anyway, we come back to our, we will not deviate, we will come back to our again alluvial deposits as aquifers, and we see that which when wells are located in highly permeable strata, for example Indo-Gangetic plain or areas which are filled with valley deposits or river valleys, bordering stream produce large quantities of water. These are the most suitable for groundwater point of view, from exploration point of view or availability of point of view. And as it infiltrates from the streams, so these streams are affluent streams, they recharge the groundwater regime very efficiently and make the groundwater available in good supplies. And the quality of water is also good in terms of their geochemical characteristics. So that kind of thing is there. Further you can see that you know that there are a lot of processes will take place when rainfall occurs in these hilly areas, and the creek meaning here is a small rivulet that is also there. So if the well is there, even in this part where the water is outwash is there, you can get water even in a hilly region, it traps. Another very important thing which is being done in this all along the rivers, major rivers of India, are these you know these wells. These are riverbed, so water is being pumped out from these river wells and riverbed wells, and this is what you are seeing here in the section in the top part also, that this river well is there, and on the higher grounds you get the water without much problem, because you are having in the little downstream you are having a river, and these wells have been constructed within the riverbed part, and they work very good for the water supply and sometimes even for irrigation purposes also. So these abundant or buried valleys, if you know they are not even perennial, still because in the monsoon time they get the water, and these buried valleys can also supply good amount of water, because these buried valleys are good for siting infiltration wells as well. So for recharging purpose also that can be done, as it is shown here also, that we can do the recharging, we can get the water. The best part here is the groundwater conditions are shallow, that means the water table is not very deep, so you can do both the process. It means withdrawing is also possible, recharging also very easily possible, because the availability of water may not be round the year, but whenever it is available, that can be used to recharge our groundwater regimes. And recharging these groundwater regimes, generally you are recharging unconfined aquifer conditions in alluvial plains, no problem. We also know that the valleys may resemble water courses in permeability and quantity of groundwater storage, and therefore their recharge and perennial yield are usually less in some cases. And the aquifers which are recharged mainly in areas which are accessible to downward percolation of water from precipitation. So this is how these penetration wells are also there, riverbed wells are also there. Now if I show a part of this Indo-Gangetic plain again here, so yellow colors you can see the shivalics, and then there are large alluvial fans which you can see here, which have been made. This is a geomorphic fluvial geomorphic feature, and this is formed when a river enters in the plain area, and whatever the sediments it is carrying, it will start depositing that sediments at the mountain front. Here the mountain front is along this HFT Himalayan frontal thrust, and in downward in the Indo-Gangetic plain. So you get these alluvial fans. These alluvial fans are also very good from groundwater point of view. So, they are because you are having sand or gravel beds, and these they can serve as a very good alluvial aquifers. So, the good large quantity of water can be made available, most of which is replenished by the seepage from the streams into alluvial fans at mouth of the mountain canyon. Because these rivers might be, if they are ephemeral, does not matter, even they can recharge the groundwater regime, and especially the part of alluvial fans. There are a series of alluvial fans along the Shivaliks in Himalaya, and they also in geomorphic or fluvial geomorphology we call them as Piedmont zone. And this Piedmont zone along the Himalaya before in the northern part of Indo-Gangetic plain or southern part of Shivaliks is very good fertile land where water is available, good quality of soils are also there. And there might be some erosional activities might be there, but that is the not much, because if rivers are not very large, but it is fine. So, the material or sediments which they are having, sandstone and conglomerate, they are sometimes cemented form of sand and gravel. So, you originally you get the sediments in loose form which are sand and gravel, and these when they are cemented they become sandstone and conglomerates. Conglomerates are generally having large boulders or large cobbles, pebbles, but sandstone is having relatively fine grained material. And if we talk about the porosity and permeability, then it is of course affected, though overall it relatively it is good compared to other kind of rocks, but the porosity and permeability of sand, sandstone and sand will be affecting because of sorting and grain size. If it is having large grain size, relatively large grain size and highly sorted, then that kind of sand or sandstone would have high porosity and permeability. But if a sandstone is poorly sorted and having fine grain, then relatively it would have less porosity and permeability. So, what I am trying to convey here, that the porosity and permeability depends on sorting and grain size, that we have also discussed. So, if I compare sandstone with conglomerates, the size is very big, but the sorting may not be good. Even then they are very good from groundwater point of view, that means porosity and permeability generally it would be high. Because the cementing might be there in case of conglomerate, but not to that extent as compared to sandstone, and the size of grains are larger. So, somewhere the openings might be available, and their porosity means sandstone and conglomerates porosity and the yield have been reduced by the cement. The cementation, this is natural cement, not artificial cement generated by humans. This natural cement, because the fine grain materials with large grain sandstone or conglomerate or sand or gravels, when it is compacted, that fine grain material serves as a cement and joins and form from sand to gravel, it forms sandstone and conglomerate. Now, these well cemented sandstones can have very low permeability, as I have just also discussed, because if interconnection between openings within the sandstone are not available, then it will bring low permeability and have hydraulic properties that are more like granite than sandstone. So, if they are well cemented, even they are sandstone by the origin, as we will call them as sedimentary rocks, but they may behave hydrologically, or their hydraulic properties might be even like granite than sandstone. So, it depends on the compaction, it depends on the cementation, it depends on the sorting and the grain size also. Further, the structures related to tectonic and depositional stresses can also affect flow in sandstone. That how, whether these are simply dipping beds or these have been folded because of some tectonic activities or stresses, and during the deposition or after the deposition, and they will also cause the they will affect the flow in the sandstone. So, if it is simply gentling or horizontal beds, the flow might be better. If this is bended sandstone or having folded sandstone, the flow might get affected because of these structural features. Sandstone aquifers yield water through their joints also. Not only the openings within the grains, connectivity, but also through the joints, because with the time these sandstones can develop joints and joint planes along which water can move also easily. So, sandstone by itself will have relatively better porosity and permeability, but because of jointed sandstone can also add on augment the this permeability also. And further, if we talk about the conglomerate, then conglomerate has the limited distribution and are unimportant as aquifers, because we do not have much conglomerates there. Like if I talk about alluvial plains or alluvial aquifers, then there not much conglomerates are there, mainly sandstone. So, if we talk about Indo-Gangetic plain, what we are having, sandstones of different sizes or sands of different sizes rather than sandstone, and clay layers in between. This is what our Indo-Gangetic plains is made of, and it is for very few hundreds of meters, it is almost same kind of structures or same kind of arrangements or layers are there. Now, if we talk about other sedimentary rocks apart from sandstone and conglomerate, then other sedimentary rocks which are limestone and dolomites, these also called carbonate rocks, they are widespread over the surface of the earth. But relative to surface of the earth may not we may not have within our this subcontinent. But anyway, they are present in many parts of India, in Rajasthan also, as well as in some other parts of India, in central India, and of course in Himalaya also. So, these rocks have extremely wide range of hydrogeologic characteristics. If it is a limestone terrain, that may we also call as karst terrain, and there things changes very frequently. Anyway, they are having good porosity generally and permeability, and that means they are favorable from groundwater point of view. However, this porosity and permeability will definitely depend on the degree of consolidation, how compact or how hard they are, and development of permeable zones after deposition. Whether because limestone is formed in the sea conditions, so whether there are some openings left or permeable zones are there during the deposition or after the deposition, that is very important. So, this density, porosity and permeability will affect these rocks, which are our in this discussion, particular discussion, we are having limestone and dolomites. Now, in limestones, openings in limestone may range from microscopic origin pores to large solution caverns, and this is because of with water it reacts, and there might be solution cavities, and these cavities can be very big. Sometimes they, if near the surface these are big, then they can make even the sinkholes, large sinkholes. So, on surface you suddenly you are having opening of your water table also. So, which will these openings will form subterranean channels, subsurface channels, water will be flowing underground conditions, and these may be sufficiently large to carry the entire flow of a stream. So, on surface you do not see any water, but below the surface few meter deep you may see a a stream. Many of you might have seen lot of caves. Generally caves are in limestone terrain, and you see that in subsurface condition when you enter the cave you find that the water is flowing in the caves. This is what the streams which I am talking about. Because of some excess on the surface it is possible to enter in these caves, but these are mostly limestone caves, and the water flows, it reacts with the rocks, host rocks, and these host rocks are then they allow the water to flow in subsurface conditions. Further, that term sometimes we also use the lost river because suddenly a river was flowing on the surface in a limestone terrain and suddenly disappears, and it may appear elsewhere also. So, that is why we call these kind of rivers as lost rivers, which are applied to a stream that disappears completely underground in a limestone terrain, but the same river may appear elsewhere after some distance. So, this is that is why many times it is real challenge for groundwater engineers to predict these hydraulic characteristics in a limestone terrain or in a dolomite terrain. So, large springs are also frequently found in limestone areas. This is again very common in Himalayan terrain also, they like Sahasrara near the Dehradun or Kempty Fall. All these areas are having limestone terrain and also having springs there as well. So, these are from groundwater point of view, the availability point of view it is good, but how much we will get is challenging compared when we compare with sandstone and gravels. Now, openings in limestone may range, as we have already said, to pores to the large solution caverns, and this lost river we have already discussed. Large openings are frequently found in these areas. If on the right side we will see a figure which is factors influencing cavity distribution in carbonate rocks, carbonate limestone, dolomitic. And what we are seeing here, that these are the remnant bedding planes which you can see like this, and they because of solutions or water actions, the openings have become, see this bedding plane is also shown, this is the fault, and all these are allowing water to move there. So, if there is a on the surface, if there is a fracture or something, the water, the river may suddenly disappear, lost river, and because it is all happening because of this material which is calcium carbonate. So, dissolution of calcium carbonate, this is what limestone and dolomite are made by. So, this dissolution, the action with the water or a chemical action by the water with these rocks, creates the cavities, caverns, big caves, all kinds of things which will cause, water causes prevailingly hard groundwater to be found in limestone aquifers, because this water is having lot of calcium carbonate, and if certain beyond the standard limits, if it is there calcium carbonate, that may be even harmful to the human beings. Anyway, that is a different aspect we will be discussing in later part of this course. Also, this dissolving these rocks water tends to increase the pore space and permeability with time. So, originally when the rocks were formed, they may not have such kind of porosity and permeability, but slowly as the movement of water is there, this will keep increasing pore spaces, that means the high porosity and high permeability, but fully unpredictable, not like sandstone and conglomerate. This is disappearing stream example is here. In this schematic on the right figure, what you see, the river is there, suddenly there is a sinkhole and the river disappears and again is reappears, but in subsurface conditions, but on surface again it can appear. So, this kind of situation is very common in limestone terrain. So, solution development of limestone forms a karst terrain, that is why it is called karst terrain, or this kind of topography is called karst topography, which is characterized by solution channels which you are seeing here, and solution channels are there which is are there, and sometimes you are having closed depressions also, subterranean drainage through the sinkholes and the caves which you can see. These are the caves where sometimes if they are having opening on the surface, people go as a tourist, or sometimes these caves also becomes a holy shrines or holy places for the prayers and other things. But most of the time wherever you would see, in 95% times these caves are made in limestone terrain, and they are all because of solution or dissolution of material or solution cavities. So, such regions normally contain large quantities of groundwater. They are full of groundwater, and springs are there, subsurface streams are there, surface streams are there, and they are very good. Now, if I look a map of India, here this dark blue color, the first one, these are the continuous carbonate sedimentary rocks which you can see in many parts of northeast India, and some parts like I earlier mentioned Rajasthan, some parts in Madhya Pradesh, and in some parts in east of South India or eastern part of India. The other kind of carbonate sedimentary rocks which are discontinuous are occupying a large area in all these parts also. All along Himalaya also it is there, and the continuous carbonate rocks are also found in the Himalayas. So, a large part of India, sufficiently large, not as large as Indo-Gangetic plain, not large as cratons and other things, but sufficient amount of these limestone terrains or carbonate rocks are found in India too. Some are continuous and some are discontinuous there. So, in India carbonate rocks including limestone, marble, dolomites are found. Marble is a metamorphosed form of your limestone or dolomite. Among these carbonate rocks, limestone occurs extensively. So, most of the time either you are getting limestone and marble also, dolomite sometimes also, and all these three calcium carbonate rocks or carbonate rocks are used for this construction purposes, for decoration, for flooring and other purposes. The slabs or tiles of marble, limestone and dolomites are used extensively in say building material, and a lot of quarries and mines you can see in these parts of India where they are finding good quality of limestone, dolomite, and of course marble is the relatively expensive than simple limestone. Carbonate rocks which are having solution cavities lead to widely contrasting permeability within short distances because of solution cavities, and that is why I have been repeatedly saying that predicting hydraulic characteristics in a limestone terrain is always challenging, because in a short distance the permeability will change, and if permeability changes then the prediction becomes much difficult. These potential limestone aquifers are found to occur. I have given examples of Rajasthan, Peninsula India, in which yield range, this specific yield range from 5 to 25 LPS liter per second. So, it is a good quantity or good yield is there. Now, when we see the large springs, we will have a separate discussion also, and probably during that discussion also this figure will come. But from limestone point of view, these large springs which exist in Himalaya or in other parts of the country are located, as I have also mentioned earlier, in limestone formations, which you are also seeing. See, from the northeast India you are seeing from Assam, you are seeing from Uttarakhand, this part you are seeing from Himachal Pradesh, and other parts of Himalaya you are seeing that these are large springs which are there. And a Himalayan range is home to about 3 million of India's 5 million springs, and that is another indication that Himalaya is having good quantity of limestone. In earlier figure you can also see that in eastern Himalaya as well as in northwest Himalaya you are having good quantity of limestone, and these limestones are very favorable for large springs. And you may not be knowing, but let me share this information, is that even our Mount Everest, the rocks on Mount Everest are also limestone. So, it is not only in lower reaches of Himalaya, but even in greater Himalaya part, which is where Everest is located, that is also a limestone terrain. These locations, limestones are, as we have been saying, because of solution activities and other things, good. They provide the springs, and sometimes quite rapidly due to natural and anthropogenic interventions. So, you may get thousands and thousands of springs, especially in hilly terrain like Himalaya. But in other parts of India, I have also seen springs. The supply of that water, or the, I would say, spring shed or water shed of that spring is maybe nearby through a pond or something. And this is again, that might be most of the time you are having a limestone terrain. This is another problem which many springs of India are facing, because of we say drying up of the springs is intricately linked to the desertification, because of nearly every river in India has its origin in springs. Except for few rivers like even Ganges or Yamuna or other rivers which are having origin in Himalaya, large part of water which is coming in these rivers is coming from springs. And there are many rivers which do not have origin in Himalaya, or they are not snow or glacier fed. If I give you example of Narmada, but it is a perennial river, and that is the source of these rivers, Betwa and other source of these rivers are through only springs. So, springs are very, very important for many of our channels. Anyway, now a last part which are among the sedimentary rocks, and there can be many. So, we have discussed sandstone, conglomerates, we have discussed limestone, marble, dolomites. Now, there is another part, other types of sedimentary rocks. Major types of sedimentary rocks is shales, which is made from very fine materials, and they are generally very poor in terms of aquifers, and they usually act as confining zones and interbedded with sandstones. So, they can, if there are two layers and in between you are having sandstone or sand, and then they can serve or provide a very confined aquifer conditions, because of very fine materials, sediments they are made from, and therefore, they can serve as confining layers, and can also create conditions where we get confined aquifer conditions. And generally we get these are layers. So, you may get some shale layers or clay layers, clay stones, and then you get sandstone and again the clay stones. So, these are interbedded with the sandstone. So, at least the sandstone, if our tube well is going to that depth where we are tapping the sandstone, then we will have a good supply of water. But if we are going only up to the shales layer, then we will not have good supply of water. Anyway, but the shales are also not completely solid, they are fractured, they may be layered, because there are layers are there, and might be these fractures might be sufficiently thick, and they too can produce enough water to supply to domestic water lands, where we do not need much water for drinking purposes, for domestic purposes. But if it is for irrigation, then it might be difficult. So, of course, the first preference for the sandstone or conglomerates, second preference might be for limestone, third preference for the shales, but if they are interbedded with sandstones. So, with this I thank you very much, and we will also have one more discussion on geologic formations as aquifers, that is part 3. So, with this, thank you very much.